Hello there folks, and welcome to video number 216. This is the last one I'm going to make, and I've dressed up accordingly. This one is on harder probability trees. I have made a probability trees video which you should watch along with a number of other videos in order to be able to do this skill very well. But the keywords are independent, dependent and conditional. Independent events are events that are not connected. Dependent and conditional events are connected. The method states, and this is kind of loose because there's lots of various different skills you need to join together to make this one work for yourself. But write expressions to represent probabilities. Set up your probability tree as usual, but use the expressions as the probabilities instead of numbers. So they're algebraic probability trees basically. Use your knowledge of algebraic fractions to multiply and add if the question requires it. Use your knowledge of solving various types of equation to find the values of x or value of x. And then use the found value of x to answer any question you may have been given at the beginning. So we'll start off with number one. John has got red and blue counters in a bag and the ratio is 3:1. Okay, he removes two counters and the probability of both being blue is 1/20. We've got to work out how many counters are in the bag at the beginning. So what we're doing is we're thinking of the ratio being R to B, which is 3:1. All right. Now we can think of that as 3 lots of something and 1 lot of something, because of every time you have one blue counter, you have 3 red counters. Okay. We don't know that the total number of counters is 4, but it's a multiple of 4. All right. Nice to think of the total, and then an expression for the total would be, if we made that 3x and that 1x, the total would be 4x. Okay, that's how I'm thinking of this question. I think it's the nicest way to think about it. We're going to start off with our tree. We're going to start off going along the blue branch, and then we're going to go along the blue branch again. We don't need to write the red branch necessarily. It doesn't really matter because we've only got the probability for the blue, and I haven't got enough space anyway. So I'm going to think of the probability of getting blue is 1x out of the total, which is 4x. All right. Now, we don't have to make this as complicated because the x's do cancel in this instance. So we can just say the probability of getting the blue counter after the first go is 1 out of 4, right? It always will be 1 out of 4, all right? So then we need to think of, though, the probability of getting a blue one again. Well, if we get 1x on the first go, we've got 1x take away 1. So I'm just going to write down x minus 1 over, and we've got 4x's take away 1. On the bottom, because there's one less counter in the bag. It's a dependent probability question, isn't it? Along the branches you always multiply, so what we're doing there is 1 lot of x, so we go in and write it down actually, 1x minus 1 all over 4x multiplied by 4x minus 1. Now we know that that probability, that's multiplied by that, will equal 1/20 because it's the probability of blue and then blue again. Alright, we're told that there, and that's what we're using that probability for. That's going to help us solve what x is. If we multiply this out, we get x minus, we get x minus 1 over 16x. Oh no, why have I put an x there? Didn't need that x. Did I need that x? No, 4. Not that one there, didn't need that one there. Right, so I've got 4, and then that's going to be 16x minus 4. I didn't need that x there because I'd cancelled it there and I'd forgotten I'd cancelled it there. Okay, so what I've got there is equal to 1 over 20. Alright, then I can cross multiply these. So 20 multiplied by x and then 20 multiplied by minus 1 is going to give me 20x minus 20. And that's going to be equal to 1 lot of this, which is the same as it is already. Then I'm going to take away 16x. It's going to give me 4x. Minus 20, one step at a time, equals minus 4. Add the 20, it's going to give me 16. 4x equals 16, and therefore x equals 4. Okay, if x equals 4, we've got 4 lots of 4, which actually is up here as well. 4 lots of 4 is 16. Okay, and that's how many counters are in the bag at the start. 16 counters. Okay, and you can always check to see if it works as well. So if we chucked that in at the beginning, we got we could just work it out and see if it did give us that ratio that was told to us in the beginning of the question. I'm not going to bother with that one. So, number 2, there are 4 baby pigs and X adult pigs in a pen. 2 pigs are removed at random. The probability that both pigs are adult pigs is 1/3. Work at the original number of adult pigs. Again, it all sounds quite complicated, but if we think of this in terms of expressions, the baby pigs is equal to 4, the adult pigs is equal to X, right? And the total number of pigs is equal to these two added up, so X plus 4. All right, there's our expression. Now we've got our tree that we can use again. So we've got A, probability of A multiplied by A, adult pig and adult pig, is going to be X out of X plus 4. Multiply that by X, take away 1 of the adult pigs, and then take away 1 from the 4, going to give us X plus 3. So what we've got is X multiplied by X minus 1 all over X plus 4 multiplied by X plus 3, which equals our probability of 1/3. Okay, now we need to multiply all this out, work out what it is, cross multiply, find out the value of X. We're going to get quadratic as well, because we've got multiply and double brackets here. So we will start doing that. I'm going to get X squared plus X over, I'm going to do this quickly, you can use your grid method to do it, but I'm going to do it quickly. I'm going to get X squared plus 7X plus 12 equals 1/3. Cross multiply. 3x squared plus 3x equals x squared plus 7x plus 12. Take away an x squared there, we got 2x squared. Take away 7x from the 3x, and why I put a plus there, it's a minus, should be a minus, therefore that's a minus. That was a mistake, or almost a mistake. There we go. So we take away 7 from minus 3x, but it was minus 10x. And then we're going to take away the 12 as well, so minus 12, that's going to give you 0. And then we can divide all of those numbers by 2, so that's going to give us x squared minus 5x minus 6 equals 0. Factorize this, see what we're doing, factorizing quadratics. So we've got 6. Factors of 6 to add to make minus 5 are going to be positive 1 and a minus 6. Again, watch the video on how to do that if you need to. Therefore, it gives us two options. It's going to give us x is equal to minus 1 or x is equal to a positive 6. Now, in context, because it's about adult pigs, it can't be minus 1 adult pigs, so it has to be 6. So work out the original number of adult pigs, 6 adult pigs. Okay, lots of work, lots of marks available for a question like that. Alright, I've almost muffed up both of these questions so far, but let's see if I can do this one without making a single mistake. It's unlikely. Now, question 3 is there are X chocolates in a bag. 8 are dark and the rest are milk. Jason takes 2 chocolates and eats them. The probability that both are milk is 1/5. Show that. So to show that question, we get one of these. I remember this kind of question in the exam paper that caused absolute uproar a few years ago, and this is a similar sort of question. It's show that you get this quadratic expression you do from these probability tree questions. Anyway, let me show you what to do. So there are X chocolates in the bag, and that's the total. So here's an expression for the total. And there are 8 dark, so dark equals 8, and then milk is going to be 8 less than the x, so x minus 8 is the expression we can use for the milk chocolates. He takes, we've got the probability of milk chocolate, so we're going to go along those branches. We're going to go m, and we're going to get our probability of milk is going to be x out of 8 over x. Okay, that's how many milk chocolates there are out of the total number of chocolates to begin with. Then we're going to take away another one. So if you take away another one from minus 8, you're going to get minus 9. So x minus 9, because we took a milk one on the first go, out of taking one off of the x there, x minus 1. All right, we're going to multiply those together. That is going to give us our expression, which is going to be equal to 1/5. So we're going to go, I might just do this quickly, so x squared, and then minus 8 minus another 9 minus 17x, and then multiplying both those negatives together is going to give us positive 72. All of that over x squared minus x equals our probability of 1/5. Okay, multiply all that by 5x squared minus, I'm just going to type that into what the calculator, 17 multiplied by 5 is 85, of course it is, and that is 85x, and then plus, it's 360, so it's 360 mine equals the x squared minus the x, because you just multiply the 1 by the x squared minus x, and we've cross multiplied those successfully. Now we just make the expression, or quadratic expression, equal to 0, and that will give us 4x squared. Add an x to minus 85 is going to be minus 84x plus 360 equals 0. All of those should be divisible by 4. 84 divides by 4 to give you 21. So x squared minus 21, I'm going to get rid of that because it looks a bit messy, minus 21x, and then 360 divided by 4 is 90. And I haven't looked to see if that actually matches, but it does. There we go, we've got what we wanted, and we've shown using the method that I've gone through in the other couple of questions as well, how we got there. Alright, now we've got to find the value of x. All we've got to do is factorize that quadratic. So we pop in our double brackets, we think of the factors of 90 that add to make minus 21. They're both going to be negative because it's 15 and 6. So minus 15 and minus 6 are the numbers. So we've got x equals either 15 or 6. And we have to choose here. We've got a choice. They're both positive numbers. So which one makes sense? So think of if we put 6 and we took away 8, 6 take away 8 makes minus 2. So therefore it can't be that one. It can't be that, because that would be a negative number of milk chocolates. Therefore it has to be 15. Okay, so find the value of x. X equals 15. And that, my friends, is that. I don't think I made a mistake on that one. So I finished all the videos for you, and I'm hoping if you've watched them all, you've done an amazing job. If you've watched a few of them, if you just watched this one, go on and watch some more, because you probably learn a bit of maths. I have taught a lot of maths here. It's a lot of hours worth of work, and it's a lot of hours worth of work for you to watch all of these and get really, really good at what you should be doing in school, maths wise. So take care of yourselves, look after one another, like, subscribe, share, but most of all, just practice and enjoy it. Alright? Thank you so much for watching, and thanks for those that have supported me since the beginning. Take care. Bye bye.